Good day, everyone. We'll be dealing with integration, right? So let's proceed. So we say integration is an important concept in mathematics, and together with its inverse, differentiation, is one of the two main operations in calculus. So we say that we use differentiation and integration for some things that are involved in calculus, right? So we say integrals and derivatives became the basic tools of calculus, with numerous applications in science and engineering. By the end of this unit, the learner should be able to evaluate both indefinite and definite integrals using different rules and properties of integration. Integrate by using the substitution method or the method which we call the U substitution, right? Determine the area between a curve and the x-axis by using the definite integrals. Determine the area between two curves. Use Simpson's rule to determine the area between a curve and x-axis. So these are some of the rules that we have to follow in order for us to solve integration problems. So we say the first rule says that it's the integral of k d of x, right? So we say that k is a constant. So if you have a constant value, then you add the value of x into it, besides it, right? Then the second rule states it's the integral of x to the power n dx is equal to x to the power n plus 1 over n plus 1 plus c, where n is not equal to negative 1, right? Then we have the third one, which says the integral of k f of x is equal to constant k integral of f of x, provided k is a constant, right? Then you have the fourth rule, which says the integral of open bracket f of x plus minus g of x close bracket dx is equal to the integral of f of x dx plus or minus the integral of g of x dx, right? The fifth rule, which is the integral of negative f of x dx is equal to negative integral f of x dx, which is a special case rule, right? Then you have the sixth one and the seventh one, which we'll be using in trigonometric integration, right? Then you say the sixth one says it's integral sine x dx is equal to negative cos x plus c. The seventh one is the integral of cos x dx is equal to sine x plus c. Now, we talk about indefinite integrals, right? So we say that if the function f of x is a derivative, then the set of all antiderivatives of f is called the indefinite integral of f, right? Denoted by the integral f of x dx. The symbol is called an integral sign, and the function f is the integrand of the integral, and x is the variable of integration. So what we'll be trying to solve, which is considered x, is the integrand or the variable that we have to work with. Once we have found an antiderivative, which is the capital letter f of x of a function f of x, the other antiderivatives of f differ from f only by a constant. So it means that the values of the derivative differ from the antiderivative only by a constant, right? So we say we indicate this in the new notation by writing the integral of f of x dx is equal to f of x plus c, right? The constant c is called the constant of integration. Yes, then we proceed. Here we have our first problem, right? Which is the integral of 3 of x, 3x dx is equal to 3, the 3 integral x dx, right? So first things first, which rule can we apply here? We can apply the rule that states that shows us that the integral of n dx, right, is equal to, the integral of x n dx is equal to x to the power n plus 1 plus 1 all over n plus 1, right? So that is the first thing that we'll do, right? So we know that we are going to use this formula for the first one. Then what do we know? What do we know about this is that x has a constant of 1 on top of it, right? X has a constant of 1 on top of it. Then we will proceed with our question. Then since we know that x has a constant of 1, then you can say it's 3, right? 3x to the power 1 plus 1, right? 3x to the power 1 plus 1 over 1 plus 1 plus c is equal to 3x over 2 plus c, right? So that is what we understand about the first question, right? Then the second one, we have the integral of pi plus x to the power 3 minus 1 over 2x squared dx, right? So we say that the integral is equal to the integral pi dx minus integral of x cubed dx minus 1 over 2 integral of 1 over x squared dx, right? So the integral of a constant, we know that we add our value, which is x, right? Our variable, which is x. Then for the second one, which is the integral of x cubed dx, we use the first rule that states that the integral of x to the power n dx is equal to x to the power n plus 1 all over n plus 1. The n represents the number or the constant that is on top of our x, right? So we say that it is equal to x to the power 3 plus 1 over 3 plus 1, which is equal to x to the power 4 over 4, right? Then we deal with our following one, which is minus 1 over 2 integral 1 over x squared, right? Dx. So we know that we can change the value of x 1 over x squared into x to the power minus 2, right? Then still we use the first rule. So we say it is 1 over 2 open bracket multiplied 1 over 2 open bracket x to the power minus 2 plus 1 all over 2 minus 1, right, plus c. Then we get our final answer, which is pi x plus x to the power 4 over 4 plus 1 over 2x plus c. So we proceed. So we have integration by substitution or u substitution. So this substitution makes things easier for us to integrate, right? So the theory is that the formula was formed through differentiation, right? Which I'm sure that you dealt with in the earlier chapters, but then we will not dwell on that much. So the general formula for this is that the integral of u to the power n du is equal to u to the power n plus 1 over n plus 1 plus c. So that is the only formula that we will be dealing with when we are talking about integration using the substitution method, right? So these are the two main problems that we'll be dealing with when we are dealing with integration, right? Using the U substitution. Okay, so first things first, what I want us to notice is that whenever we are dealing with U substitution, whatever is inside the brackets, we have to change it into U, right? So we say let x plus 2 is equal to U, right? Then after that, we differentiate. So it's d open bracket x plus 2 over dx is equal to 1, right? So we differentiate what we let u become, which was x plus 2, right? So if we differentiate this, we get the value of 1. So after that, we say we have to cross multiply in order for us to get the value of du, right? So we multiply both sides by dx, right? Multiply both sides by dx. So this side, on the left hand side, they cancel each other. Then you have du is equal to dx, right? So now we are aware that our new equation now is u to the power of 5 dx, right, is equal to u to the power of 5 du, sorry, is equal to u to the power of 5 du, right? Then we know that the formula for the u substitution is u to the power n du is equal to u to the power n plus 1 all over n plus 1 plus c, right? So we are aware of that. Then let us proceed into solving our problem. Then we are given the value of n, right, which is 5, and we also know that this new equation of ours, which is u to the power 5, is also as the same equation as the integral of x plus 2 to the power 5 dx, right? So let us proceed into solving it. Then we say the integral of u to the power 5 du is equal to u to the power 5 plus 1 all over 5 plus 1 plus c, right? Which is the same as u to the power of 6 all over 6 plus c, right? But we are also aware that the equation of u to the power 6 can also be written as x plus 2 to the power 6 all over 6 plus c, right? Sorry, plus c. So that is the first problem that we have solved. Then we go to the second one. The second one, let us remove all this. Let us remove all that we have noted down. Okay, then we go again. Now we say let 4x minus 1 equals to u, right? Then we say d to the power 4x minus 1 divided by dx is equal to, then we differentiate this, which is 4x minus 1, then we get that it is equal to 4 only, right? Then we cross multiply dx in order to cancel it out on both sides. Then you say it's d it's 4 dx, right? Then we get that du over du is equal to 4 dx, right? But we are looking for dx. Then we say dx is equal to 1 over 4 du, right? Then we get that. Okay, then our equation now is it's u to the power 3 du 1 over 4, right? 1 over 4. Then we say, using the equation of u to the power n plus 1 over n plus 1 plus c, right? Sorry for the ugly c. Then we say it is u to the power 3 plus 1 all over 3 plus 1 plus c. Then we can write it in the form that we know it, which is if we write it with using the original values as 4x minus 1 to the power 4 all over 4, not forgetting that it has the 1 over 4 that we have to multiply with 1 over 4 plus c, which gives us pretty sure it's 4x minus 1 to the power 4 over 16, right? Then we can proceed. Okay, so now we'll be dealing with integration involving trigonometric functions. So we will not be, in this lesson, we'd rather be focusing on solving them using the u substitution, which I feel like is much easier for students, right? But then sometime later on, we'll be using the formulas, right? So now these formulas, you have to know them by heart. You really have to know them by heart. Okay, so now we are given a problem which says evaluate sine 3x dx, right? It says evaluate sine 3x dx, right? So we said that whatever that we are given that is in between the brackets or the function, we have to let it become, let 3x become u, right? We say that is equal to u, right? Then we say d 3x all over dx is equal to 3, right? Then we multiply both sides by dx, right? Multiply both sides by dx, then the dx on the left hand side, they cancel each other out. Then we are left with du is equal to 3 dx, right? 3 dx. Then we say that the value of dx is equal to 1 over 3 du, right? 1 over 3 du, 1 over 3 du. Then we say that we can also write it as in 1 over 3 sine sine u du, right, is equal to minus 1 over 3 cos u, cos u plus c, right? But we are also aware that sine 1 over 3 sine u du is equal to this thing of ours, which is sine 3x dx, right? Then we can also write it as minus 1 over 3 cos 3x plus plus c, right? Then you can also write it in that manner, right? Then we proceed, we go to integrals involving exponential and logarithmic functions, right? So these are the rules. These are the three general rules that you have to understand, whereby it says the integral of f prime of x multiplied by a to the power f of x dx is equal to a to the power f of x divided by the natural log of a plus c, right? That where a is greater than 0 and is not equal to 1, right? Then we say the second one states that is the integral of f prime of x e to the power f of x dx is equal to e to the power f of x divided by the natural logarithm of e, which is equal to e to the power f of x plus c, right? Then the other one is f prime of x over f of x dx is equal to the natural log of f of x plus c, where f of x is greater than 0 and it is not equal to 1, right? Then this is the problem that we are given, right? So the first things first, right? We see that this is our function f of x, right? This is our function. And we see that this is the derivative or f prime of x, right? F prime of x is equal to 2, right? So now we said that if ever you have f prime of x and a f of x, then the formula that you will use is this one, which states that a to the power f of x over the natural log of a, right? Then we say that the solution for our integral, this one, is a to the power f of x. Our a here is 3, right? So we say it's 3 to the power 2x all over, what is the natural log of a, all over the natural log of 3 plus c, right? Okay. Then now we proceed to the questions that we have gathered for us to solve. We have to understand integration by parts, right? You have to understand integration by parts, right? So integration by parts says that u dv is equal to uv minus v du, right? So that is something that we'll deal with the upcoming semester, but for now we have to be able to understand it um, during the questions that we are going to answer now, which is unfortunate that we can't dwell into detail of how how we should put this out, right? So now, for us to solve questions involving integration by parts, we have to understand what this liate means, right? So this liate means that if ever you are dealing with problems, the first thing that you have to solve or let equal to be u, right? The first thing that you have to let be equal to u, you have to follow it in this Lie manner, right? Which is logs, inverse trigonometric functions, algebraic functions, trigonometric functions, and exponential functions, right? So it's logs, inverse trigonometric functions, algebraic functions, trigonometric functions, and exponential functions, right? So we'll look at some few problems here that will cover. Um, so the first one we have to integrate as e to the power psi e to the power x multiplied by sine 3x, right? That is the first one that we have to integrate. So let us write it down. Then you say it's e to the power x multiplied by sine 3x dx, right? dx. So we have to follow Lie when we are integrating by parts. We follow Lie, right? Which deals with logarithms, inverse trigonometric functions, algebraic functions, trig functions, and exponential functions. So now the first thing that we have to check is which one comes first. So we have trigonometric functions, which is sine 3x, right? Then it is followed by an exponential function, which is e to the power x, right? So after that, we say let sine 3x equals to u, right? Then you say e to the power x multiplied by dx equals to dv, right? So it all comes from the formula of u dv is equal to u v minus the integral of v du, right? So that is where it comes from. So now, firstly, we determine du, right? So we say du over dx is equal to, so we know that the value of u is sine 3x. So if we differentiate it, we get that it is 3 cos 3x, right? Then you say that du is equal to 3 cos 3x dx, right? Then we also have to determine what is the value of v, which is integrating. Then you say v is equal to e to the power x, right? V is equal to e to the power x. So now when we go to substitute into our equation, we get the value. What is the value of u? The value of u is sine 3x. What is the value of dv? The value of dv is e to the power x dx, right? Is equal to, so what is the value of u? The value of u is sine 3x. What is the value of v? It's e to the power x, right? minus the integral of the value of v is e to the power x. What is du? Du is equal to 3 cos 3x dx, right? So we understand that. Then we proceed to continue. Then we have to solve for the integral of cos 3x dx multiplied by ex, right? So still we follow the same procedure. We determine the value of the derivative of cos 3x. Then you say d3 cos 3x over dx is equal to negative 3 sine 3x. Then we say du is equal to negative 3 sine 3x multiplied by dx, right? Then you say that the value of v is equal to e to the power x, right? So we say that it's e to the power x. So we say when we continue, still we do not forget our formula uv is equal u dv is equal to u multiplied by v minus the integral of v du. So what is the value of u? The value of u is cos 3x. What is the value of e? The value of e of v is e to the power x minus the value of v, which is e to the power x multiplied by negative 3 sine 3x dx, right? Dx. So now, since we have got all this, we've got that cos 3x multiplied by e to the power x minus e to the power x multiplied by negative 3 sine 3x dx is equal to cos 3x dx. Then we go back to the original equation, which was this. Then we substitute everything that we have there. Then now our equation will be sine 3x sine 3x e to the power x dx is equal to sine 3x multiplied by e to the power x minus 3, right? So from here, for the integral of e to the power x 3 multiplied by cos 3 x dx, we substitute what we got here, which was cos 3x minus e to the power x minus the integral of e to the power x minus 3 sine 3 dx, right? Then we substitute that there. So it's cos 3x multiplied by e to the power x minus 3 plus 3 integral of sine 3x e to the power x dx, right? So we can see that then it is equal to sine 3x multiplied by e to the power x minus 3 cos 3x multiplied by e to the power x minus 9 sine 3x, the integral of sine 3x e to the power x dx, right? Now we can see that we have the similar function of the integral of sine 3x multiplied by e to the power x is the same as that of the original equation, right? So now what we do here is we say, so it's going to be 9 integral of sine 3x multiplied by e to the power x dx plus the integral of sine 3x e to the power x dx is equal to, what do we have on either side, is equal to sine 3x to the power ex minus cos 3x to the power ex, right? Then you have sine 3x to the power ex minus 3 cos 3x multiplied by e to the power x, right? Then you say now we have 10 integral of sine 3x multiplied by e to the power x dx is equal to sine 3x multiplied by e to the power x minus 3 cos 3x to the power ex. So that is our solution. Then we are not done simplifying. Then we divide both sides by 10 by a 10. Divide both sides by a 10. Then our final solution is sine 3x multiplied by e to the power x dx is equal to sine 3x multiplied by e to the power x minus 3 cos 3x multiplied by e to the power x all over a 10, right? Plus C. Okay, so now we'll be dealing with our second problem, which is y is equal to sine cubed x cos cubed x. So we have to integrate this sine cubed x multiplied by cos cubed x dx, right? So that is what we have to integrate, right? So firstly, we can simplify this in order for us or our problem to be easier to deal with, right? Then we'd simplify it by sine cubed x cos squared x multiplied by cos x dx, right? So we know that cos squared x is equal to 1 minus sine squared x, right? That is what we know. So let us proceed in solving this. Then you say it's sine 3 sine cubed x multiplied by 1 minus sine squared x multiplied by cos dx, right? Then after that we say let sine x, right, is equal to u, right? Then we say du, we derive du over dx, right, is equal to cos x dx, right? So now our equation changes into u to the power 3, 1 minus u squared du, right? Du. So now we can further simplify it into u to the power 3 minus u to the power 5 du, right? Then it's u to the power 3 du minus u to the power 5 du, right? Then you say it's u to the power 3 du minus the integral of u to the power 5 du. It is the same as saying u to the power 3 plus 1 all over 3 plus 1, right? Minus u to the power 5 plus 1 all over 5 plus 1 plus c, right? Then we know that the value of u is sine sine to the power 3x dx, sine to the power 3x, sorry, so it's sine to the power 3x cos dx minus sine to the power 5x cos x dx is equal to, so we know the value of u, we said that it is sine x, right? So we say it is equal to sine x sine to the power 4x or over 4 minus sine to the power 6 6x all over 6, right? Okay, so now we'll be dealing with our second problem, which is y is equal to sine cubed x cos cubed x. So we have to integrate this. Sine cubed x multiplied by cos cubed x dx, right? So that is what we have to integrate, right? So firstly, we can simplify this in order for us or our problem to be easier to deal with, right? Then we'd simplify it by sine cubed x cos squared x multiplied by cos x dx, right? So we know that cos squared x is equal to 1 minus sine squared x, right? That is what we know. So let us proceed in solving this. Then you say it's sine 3 sine cubed x multiplied by 1 minus sine squared x multiplied by cos dx, right? Then after that we say let sine x, right, is equal to u, right? Then we say du, we derive du over dx, right, is equal to cos x dx, right? So now our equation changes into u to the power 3, 1 minus u squared du, right? Du. So now we can further simplify it into u to the power 3 minus u to the power 5 du, right? Then it's u to the power 3 du minus u to the power 5 du, right? Then you say it's u to the power 3 du minus the integral of u to the power 5 du. It is the same as saying u to the power 3 plus 1 all over 3 plus 1, right? Minus u to the power 5 plus 1 all over 5 plus 1 plus c, right? Then we know that the value of u is sine 3 to the power 3x dx, sine to the power 3x, sorry, so it's sine to the power 3x cos dx minus sine to the power 5x cos x dx is equal to, so we know the value of u, we said that it is sine x, right? So we say it is equal to sine x sine to the power 4x all over 4 minus sine to the power 6 6x all over 6, right? So now we have our other question here, which is y is equal to cosec 2x minus 1 multiplied by cot 2x minus 1. So we have to integrate this. So now we say the integral of cosec 2x minus 1 multiplied by cot 2x minus 1 sorry, dx, right? So we say for us, then we say let cot 2x minus 1 equals to u, right? Now, after we've done that, we have to find the derivative of u. Then we say du over dx is equal to negative cosec cosec 2x minus 1, right? Then du is equal to negative cosec 2x minus 1 dx, right? Then you say it's negative du is equal to negative cosec, sorry, it's not negative, it's positive cosec 2x minus 1 dx, right? Then we go change our equation into u, negative integral of u du, right, is equal to minus u plus u to the power 1 plus 1 over 1 plus 1 plus c, right? Then you say it's equal to minus u to the power 2 all over 2 plus c, right? Then, which can also be reverted back to its original state, that is the integral of cot 2x minus 1 multiplied by cosec 2x minus 1 dx is equal to negative cot 2x minus 1 squared, all divided by 2 plus c, right? So that is the final solution. Okay, so here is another problem that we have to deal with, which is we have to integrate y is equal to x multiplied by cos 3x. So let us write it down, right? So we say the integral of x multiplied by cos 3x dx, right? Then we follow Lie8. We have to follow Lie8. So what does Lie8 mean? We have to look for logarithmic functions, inverse trigonometric functions, algebraic functions, trigonometric functions, and exponential functions. So the first one that is present here is the algebraic function x, followed by the trigonometric function, which is cos 3x, right? Then we say that whatever we find first, we let it become u. So we say let x equal to u, right? Then we say let cos 3x dx equals to dv, right? Then we now have to find the derivative of du, right? We say du over dx is equal to 1, since we know that if we differentiate x, then we will be left with 1. Then we say du is equal to dx, right? Because multiplied using dx on both sides, right? Then now we have to determine the value of v, right? So the value of v here, it is 1 over 3 sine 3x, right? So we have our equation for integration by parts, which is u dv, right, is equal to u multiplied by v minus the integral of v du, right? So do you have the value of u? Yes, it is x minus cos 3x dx is equal to x multiplied by 1 over 3 sine 3x minus the integral of 1 over 3 sine 3x dx, right? So now we have to determine the integral of 1 over 3 sine 3x dx, right? Let us determine the value of the integral. So we say that it is 1 over 3 integral sine 3x dx, right, is equal to minus 1 over 3 multiplied by 1 over 3 cos 3x plus c, right? Then we go back to the equation, the original equation, which is x multiplied by cos 3x is equal to 1 over 3x multiplied by sine 3x minus 1 over 3 multiplied by 1 over 3 multiplied by negative cos 3x plus c. So the final solution is 1 over 3x multiplied by sine 3x plus 1 over 9 cos 3x plus c. So this is our final question that we'll be dealing with, which is y is equal to e to the power 2x multiplied by sine x, right? So we have to integrate the question. So we say it's integral of e to the power 2x multiplied by sine x dx, right? So we use Lie to solve the problem that we are presented with. We check for the logarithms, the inverse trigonometric functions, the algebraic functions, trigonometric functions, and the exponential functions. So here, present now, we have trigonometric functions and we have exponential functions. So what comes first? It is the trigonometric function. So we'll say let sine x equal to u, right? Equals to u. and e to the power 2x multiplied by dx is equal to dv, right? Is equal to dv. Then now we have to differentiate sine x, right? Then you say du over dx is equal to cos x, right? Then you say du is equal to cos x multiplied by dx. So how did we come about that? We cross multiplied both sides by dx, right? So on the left hand side they cancel each other and it multiplied on the right hand side, right? So now we have our original equation for integration by parts, which is u dv is equal to u multiplied by v minus the integral of v du, right? So we write down everything. Sine x multiplied by e to the power 2x dx. The value of u is sine x. The value of v is e to the power 2x, right? Minus e to the power 2x cos x dx, right? Cos x dx. So now we have to integrate e to the power 2x multiplied by cos x dx, right? So still we follow the same procedure. Then we say let cos x equal to u and let e to the power 2x multiplied by dv equal to multiplied by dx, multiplied by dx equals to dv, right? Then you say du over dx is equal to negative sine x, right? Then you say du is equal to minus sine x dx, right? Then you say v is equal to e to the power 2x, right? So we say it's e to the power 2x multiplied by cos x multiplied by dx is equal to e to the power 2x multiplied by cos x minus the integral of e to the power 2x negative sine x multiplied by dx. So we take all that we got here and we go and substitute it into the original equation. So as we proceed, our problem goes as it's e to the power 2x multiplied by sine x dx is equal to e to the power 2x multiplied by sine x minus e to the power 2x multiplied by cos x, right? Minus e to the power 2x multiplied by cos x plus the integral of e to the power 2x multiplied by sine x dx, right? Then you say it is equal to e to the power 2x multiplied by sine x minus e to the power 2x multiplied by cos x minus e to the power 2x multiplied by sine x dx, right? So now we see that we still have the same thing, which is e to the power 2x sine x dx, and the same thing. So what we do is we add them together. So now we have 2 integral of e to the power 2x multiplied by sine x dx, right, is equal to e to the power 2x multiplied by sine x minus e to the power 2x multiplied by cos x, right? Then we divide both sides by 2. Then we have our final solution of e to the power 2x multiplied by sine x dx is equal to e to the power 2x multiplied by sine x minus e to the power 2x multiplied by cos x all over 2 plus c. Thanks for watching, everyone. We'll proceed with some questions during later lessons that will provide